Greetings, my name is Mike and welcome to the video on this very special day. Now, it's special because I wanted to share something that's been on my mind, and that's definitely the only reason that it's a special day. Now, this is something that I have been thinking about for at least 4 or so days, so my reasoning here is going to be pretty sound. Now, as all Android devs know, or think they know, Kotlin is the way of the future. However, I disagree. I think that Java is best for Android development. I'm going to talk about my top 5 reasons why I say this, but there are plenty more, trust me. You'll also notice a pattern with most of these 5 reasons, and that is being explicit while coding. Having a lot of magic behind the scenes is bad for this, and you'll see why when I get to some examples. The first reason I've got is maybe going to be an underappreciated one, but it definitely does make a difference, and that is faster builds. Builds are going to be faster for Java-only apps for a few reasons here. Firstly, Java has just been around longer, so it's a more mature and more developed language. This means that the compiler is going to be faster to run, and the IDE support in things like IntelliJ is going to be a lot better, and Android Studio for that matter, since they're kind of similar. Secondly, adding Kotlin support just involves adding more steps to the build process, which is just going to slow things down in general. First of all, you have to add a build script dependency, which is just going to slow down the Gradle project while it tries to load up. Then you have to apply various plugins depending on what you need for Kotlin, and that's just going to slow down your builds because it adds Gradle tasks to compile Kotlin, and just, it's going to just take longer. Then you have to configure the JVM target for some reason. This doesn't slow down the build really, but it just seems like unnecessary config that you have to do in my opinion. And finally, you have to add a Gradle dependency on the Kotlin standard library, which just ends up making your APK a bit bigger. And you also have to add a dependency on the coroutines library if you do want to use that for some reason. Next up is nullability, and what can I say here other than Java just does it better? Right, in Java you can use annotations, which is basically like metadata, to say that, hey, this thing might be null or this thing will never be null. Whereas in Kotlin, you have separate types for nullability, which just complicates stuff a lot. Another nice thing with it being metadata is that it's optional, so you can leave it out if you want to make your code even neater. And this is good because it means you don't have to care about nulls if you don't want to. Like a lot of times, in the Android world, we know something is not going to be null, like if you're in an activity or fragment, the context, So in that case, it's just a lot simpler to just reference the field or the method directly without having to be overly defensive about your programming. Anyway, let's have a look at what I mean. So this is what a fragment would look like in Kotlin, and say I wanted to get some extras from the activity's intent, right? This is obviously going to break for Kotlin users because it's nullable. So you can't just say dot. You have to either say question mark dot, or an alternative is to just use the double bang operator. And this will work, but it ends up looking quite ugly, and it's like, what's going on here? Are these even method calls anymore? Like, it just looks so bad. And similarly for this one, you would also have to do something there. And another side note here is that, what is this property access syntax thing? Like, it wants me to pretend that it's a field, this title thing, but if I go to it and if it loads, you'll see that it's just a method call. Like, why does it warn me to use property access syntax? No man, go away. Anyway, to relieve myself a bit, I'll look at the Java side. Over here, it's doing the same stuff, but you can see that we just say dot, because we know that the activity is going to be there in onViewCreated, and it has intent, and it's going to have our extra, so you can just say dot 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 and it's all fine. Now the IDE does warn you here. For some reason it says that this method invocation may produce a null pointer exception, but the keyword here is may, really. As I said, we know better about what's going on, so we can pretty much just ignore it. If you Alt-Enter on it, you get some options to suppress the warning, which is quite nice, because you can just add a comment, and then the warning is gone. Pretty awesome, and definitely nothing can go wrong here. Next, I wanted to chat about methods, or functions as they're called in Kotlin. And as you may know, these are a pretty important construct in most languages. So they need to be clear about what they're going to do without really implying things for you. And they should also do it without having strange side effects, which I'll show off shortly. Now, a great feature of Java is that all methods need to be inside a class, which just leads for great structuring of methods. And this does fix a few problems that Kotlin introduces, in my opinion. So I wanted to show a few of those cases here. The first one is in Kotlin, you can have top-level functions, which somehow can exist outside of a class. And this is not great because it pollutes the global namespace, which means you can just call this function from anywhere without having to really do anything or use any class. And it just seems super random to have that, if I'm honest. Whereas in Java, you would have something like this. You would have some kind of a nice util class with a static method inside which does the same thing. Now this is great because to call this method, you have to know that, okay, I'm going to use string util dot random UUID. Much better than the Kotlin version, which is just calling the function directly without having a class, in my opinion. And this is very similar for extension functions in Kotlin as well, where you could have something like this, which counts how many letters there are in a string. This also pollutes the global namespace because you can call this function from anywhere as long as you call it on a string, of course. However, in Java, I would say you should have, again, another static function in a util, which just has the same code inside and takes in a string. Again, much better because you have to say string util dot count letters instead of just magically calling a function on a string that is not really part of string, but it wants to be. Anyway, moving on. Next is static functions in Kotlin. And these look really weird to me because you have to put them inside a companion object. What does that even mean? And then you put your function in there and then it becomes static somehow. You can just call it on this class without an instance. Not great, more nesting and looks quite ugly, but in Java, of course, you can just write a normal method inside a class and mark it as static and then have the same code inside and it looks a lot better. So good job, Java, on that one. The next point is something that really grinds my gears, and that is higher order functions. And trust me, it sounds fancier than it actually is. But what this is, in Kotlin, you can actually pass functions around as though they were normal primitives or objects. So you can pass functions to parameters or return a function from a function. Did I even say any of that right? I'm just confusing myself by saying all of this. But let's just have a look at an example here. If I had a function to count how many items in a list match a condition, right, you could pass in a function like this. You give it a parameter name, which is fine, but then you have this weird syntax where you have the parameters that the function takes here and then an arrow and what it returns. And this to me is what's even going on here? I mean, it's just so unreadable and hard to understand. And it turns out that this over here is how you would call that function. You would build up your list, which is cool, and then you would call a function, pass in the list. But then here it gets weird, where you're not passing in a normal parameter like you would over here if you had comma and then you put stuff. Instead, you have separate parentheses or brackets, whatever, and then you put your logic in there for this higher order function. It's just so confusing as to what's going on here. I just can't even follow anymore. But in Java, we do it properly, where you either pass primitives around or proper objects, none of this function stuff. So an example, we would again have a count function which takes in some items, but now we have a predicate object that we also take in as well. And this is pretty straightforward. It looks like this. It's just an interface with a single function. Does this item match the given condition? Pretty straightforward, and I love that it can be an object now. I do love giving things nice names, so this really does help me out. And how this would be used is like this, where I've taken the liberty to create a class that implements this predicate. I've called it isEven predicate. So in here we just check, does the given item divide by 2, without a remainder. And then that's nice because I can again create new classes with awesome names, and I just love inheritance so much. And then to use it, I'll do something like this, build up the list similar to Kotlin, and we just call the function, pass in the list, pass in a new instance of the isEven predicate, and boom, we are done. The last thing I wanted to speak about, I wanted to mention this explicitly because one of my friends, PJ, told me that it's one of his favorite features in Kotlin, and that made me question him a bit. So just take a look at this. In Kotlin, you can write what they call an infix function. Let me just give more space here. That doesn't really help. But anyway, we can have an infix function, which just must have one parameter. And the weird thing about this is you don't need to use brackets when you call this function. So this one over here will just join two strings together and put a space in between. And you can call it like this over here. You just have one string and you say concat and then you say the other string. And then this is still a function call apparently, even though you don't have brackets anymore. Like, how is this even a thing? How is this readable and understandable? I mean, it's almost like you're writing just an English sentence over here. So, yeah, this really made me question PJ, especially since he's a GDE. So I thought he would have a bit more knowledge on this, but I guess not. Next up is something that's really close to my heart, and that is model classes. Now, these are just classes that pretty much store some data to represent a domain object in your app. They don't have much logic in, they just store some fields inside of them, and Java does a great job of this, and I'll show you why. Right, this is coming back to being explicit when you write code, as I mentioned at the start. The Kotlin side has a lot of magic involved. As you may know, everyone raves about this data class thing that Kotlin has, where if you add the data modifier to a class, you suddenly get a whole bunch of extra functions on that class without knowing it. How is that any good? So I had to go and read the documentation to actually figure out what is a data class and what is inside. And it turns out that it adds these functions here. Equals and hash code, toString, component n, like what even is that? And a copy method thing. So it adds all of these behind the scenes without you even knowing about it, and it's just so bad because you don't have any control over them and you don't know what's happening inside those methods. Whew. And if you want it to be parcelable, as a lot of stuff in Android is, they have this lovely parcelized annotation which you can put on it, and then you make it implement parcelable, and then somehow that works. Like, you're implementing an interface, but you're not implementing any of its methods explicitly. That happens for you, and man, this is just giving me a headache thinking about this. Anyway, the Java side of things, I wanted to actually code live because it just makes me so happy to do this. So as you can see, I've got all the fields that I have on the Kotlin side, but it's obviously red because we haven't set them to anything. So what we can do is pretty much just Alt-Enter our problems away, or Alt-Insert as well. We can generate a constructor and then we can include all the fields in there. And there we go. It's as easy as that. The IDE is pretty much doing all of this for us. And of course, we would want some getters to get each of those properties since they are private. Again, Alt-Insert your problems away. Next up, because it is a model after all, we want to implement equals and hash code methods. Once again, Alt-Insert, and you get all these lovely suggestions that you can just press enter without reading. And then look at that, how amazing is this? We get some nice equals and hash code methods generated for us without much thought at all. Finally, in the Android world, parcelable models are quite necessary to pass them around between screens. Now, you can Alt-Insert this again, but you do need to install a plugin in Android Studio to actually get this option. Why is it at the bottom of the screen? Right, this parcelable option here, you have to install a plugin, but that's fine because it's really necessary in this case. Include all the fields in it, and there we go. And we get this one, which doesn't work. Anyway, look at this nice parcelable implementation that we get, which is pretty great, and it works, and implements the interface for us as well, which is great. And I'll make this final, because I don't want anyone extending that. But how amazing is this? Look how explicit we've been when writing this model class. We can now see exactly what is inside the class and what's happening and what's going on. Now, there is one thing to keep in mind though. Not a bad thing though, just to keep in mind. That is, in future, if you want to add a new field to this class. Say if I wanted to add like a date that it was published. Right? Obviously you'll need to add a constructor parameter and getter, but the important thing is to remember to update the equals, hash code, and parcelable stuff if you want to. A lot of Kotlin people will say that, oh, this is bad because you will forget to do it and then it'll break your model and you're going to have weird unexpected problems. But I say that they are wrong, because having to do all of this stuff gives you a lot of control over what's going on. And again, being explicit. Sometimes you might not want to include a field inside of the equals or hashcode methods. Then you can just not include it. It's easy. Sometimes you don't want to include a field in the parseable implementation. Again, just leave it out. It's fine. Whereas on the Kotlin side of things, you don't have a choice because it's all happening for you behind the scenes and you just have to go with it. So I say Java is better in this case for models because we are being super explicit and it gives you that degree of control over your implementation. And the final thing I want to talk about is a great topic for discussion, and it is asynchronous operations. Now, I could make a whole video on why suspending functions in Kotlin are bad, but maybe I'll get to that this time next year. Basically, it comes down to there being so much magic behind the scenes when you write suspend. I mean, it ends up passing this whole other magical continuation object around to keep track of what's going on. I mean, there's people even write articles about what's going on in coroutines under the hood. I mean, to me, why is this necessary? Why do you need to write articles for people to understand what's going on? Oh, sorry, a bit of a rant there. Now, I feel that async tasks are the way to go for doing background work in Android. And I also think that the team has made a huge mistake in deprecating this class. Luckily, it's not deleted yet, so you can still use it. But if they do delete it in future, we can just copy the source code into our projects and continue to use it. So no real issue there, I think. So what I've got here is a simple little view model, which just has an on-button click method, which will do a fake service call, basically. It will show and hide loading when applicable, and it will update a text live data with what we get back. But this is what it would look like on the Kotlin side, and it's quite disgusting, to be honest. You would start off by launching a coroutine on the view model scope, which again is a magical extension property. And I've already ranted about this, so I'm not going to go over it again, but it's just so bad. Anyway, you launch your coroutine and then you do your necessary operations in here. Show progress, fetch the data, update the result, and then hide loading. Right? And we would have the repository, which is very simple. Oh, by the way, you'll note that I am doing dependency injection here. Clearly, I know what I'm doing, okay? So you should trust me what I'm saying here, please. Anyway, the repository, we would just like switch to another dispatcher context thing, somehow switch to a background thread without really starting a new thread, and then we would do the service call over here and return the result. Okay, that's the Kotlin side, whatever, who really cares about that? Let's get to the interesting stuff, which is the Java side using async tasks. Man, I can't wait for this. So similarly, we would have a view model here, which has the live data fields, and we're injecting the repo instance. Straightforward, the same thing. However, when the button is clicked, now we are creating a new async task, yes, and then we execute it. Pretty straightforward. If I look at the task itself, I'm passing in the repo instance, again, dependency injection, very smart. But I also take in a listener. Now this listener is at the bottom of the class here, and it allows us to basically get updates on what is going on inside the task. For example, I've got these three over here. This one would be used to show loading before the task executes. Likewise, after it executes, we could hide loading. And then when we get a result, we can again tell the view model that, hey, it's done. So the task itself is pretty simple, I think. We just override the pre-execute method and call the listener. And for doing background, of course, we override it. And this is where we'll be on a background thread, where we can then call the repository. Finally, on post-execute, we tell the listener we are done, so we can hide progress. And then if we do get a non-null result back, we can just tell the listener, here's the data. In the view model, I make the view model extend or implement the listener actually, you can see here. And I've got the three methods over here that we saw earlier. On pre-execute, I just set the loading to true. I set it to false when it's done. And then when we get a result, we update the text live data. Pretty nice and pretty awesome to look at, I think. Again, we have a lot of methods that are sort of dedicated to doing one thing only, so it's very readable and easy to follow. Now, just to show off the repo quickly, nothing special at all. It's just a normal function, which we should call on a background thread. And here we just emulate a service call, taking a few seconds to run, and we would then return a result. So nothing fancy in the repo at all. It's mostly the async task and the view model where all the fun stuff happens. Now the Kotlin one to me feels almost too easy. It feels like you're missing a few things here, like switching threads or something, because there's just too little code. And to me, it doesn't make sense. I mean, where's the background thread and where's the main thread and what's even going on? No, I can't look at that anymore. Sorry, I need to open up the Java one. Let's open up two at once to take in all the Java goodness that we can. Anyway, that's all I've got for the last of the 5 points and pretty much for the whole video. I hope that you were enlightened by what I've showed off here, and that you can understand where I'm coming from. And hopefully you can take the similar approach to me to convert everything back to Java code, because I think it really is the way to go. Anywho, thanks for watching. Hope you enjoyed, and happy April Fools. See you next time. Cheers for now. Now, I feel that async tasks are the way to go for doing background work in Android. And I feel that the team has made a huge mistake in... I can't. Straight face. Next up, since it's a model, we do want to actually implement equals and hash code. This is very similar because you can just call this function anywhere, as long as you call it on a string. But what I would... What? Where do these sounds come from? But we use that to then launch a coroutine, what does that even do? Why's my nose dying? The next one is something that really grinds my gears, and that is... What are they called? High order functions.